Hello everyone, this is Shankar. In this video, we will discuss the power electronics questions given in ISRO 2023 exam. This exam was held in the last week of December 2023. Now let us go to the questions. The first question, the latching current of an SCR is 18 milliampere. What is the holding current? Okay, so that is the question. So generally, in case of SCR, latching current will be approximately 1.5 to 3 times of holding current. So what do you mean by that? Holding current is always less than latching current. From the given options, it is 10 milliampere. Suppose if in the options, if one more value also given, then by using this equation, you can select any one appropriate option. Let us go to another question. A single phase half wave controlled rectifier has 400 sine of 314t as the input voltage. So from this data, you can simply draw circuit diagram, single phase half wave controlled rectifier. That means some resistive load is connected to sinusoidal source through an SCR. Alpha is given, firing angle for an SCR is given 60 degree. Then what is the average output voltage? V0 is equal to Vm divided by 2 pi into 1 plus cos alpha. So what is Vm here? 400 divided by 2 pi into, as cos alpha is given 60 degree, cos alpha will be 1 by 2. That means 400 divided by 2 pi into 3 by 2. So 4 will cancel 400 100 times. Then 300 divided by pi in volt. So option B is an appropriate answer. Another question. The turn on time of an SCR with inductive load is 20 microsecond. So that is T on is given 20 microsecond. The pulse train is 2.5 kilohertz. What do you mean by that? What is one cycle time? 1 by F, that is 1 by 2.5 into 10 power 3. So you will get this value is equal to 40 microsecond. It is also mentioned that Mark to space ratio, that means turn on time divided by turn off time ratio is 1 by 10. What does it mean? When there is one part of the turn on time, there are 10 parts in the turn off time. Therefore, you can define duty cycle ratio T on divided by total cycle time is equal to 1 by 11. Okay, because turn on time plus turn off time, it will give you the ratio 11 parts as a total time. Now, what you have to do, you need to calculate pulse width from the gate drive circuit. So what is that? D multiplied with T. Suppose if this pulse width is greater than turn on time of an SCR, what do you mean by that? Until SCR is turned on, external gate drive circuit is supplying pulse to the device. So then it will turn on. If this pulse width is less than turn on time of the SCR, then the device will not turn on. So I can say here 1 by 11 into 40 microsecond, this value will come around 36.6 microsecond. As pulse width given to SCR is greater than turn on time of the SCR, what will happen? It can turn on the device. or device can successfully turn on. So option A will be the correct answer. Another question. In an inverter with fundamental output frequency of 50 Hz, if third harmonic is eliminated, then frequencies in Hertz of other components in the output voltage. So what is the basic idea here? If third harmonic is not there in the output, then what happens? All triple N harmonics also absent. All triple N harmonics also absent. So if you write down what all the harmonics present in the inverter, that is basically odd numbers 1, 3, 5, 7, 9, 11, 13, 15 and so on. Out of this, if I simply remove multiples of 3 triple N harmonics, and the remaining harmonics will be present in the inverter output, where this 1 represents the fundamental component, where this 1 represents fundamental component. Therefore, what are the remaining harmonics? Fifth harmonic, corresponding frequency will be 5 into 50, 250. Seventh harmonic, 7 into 50, that is 350. And 11 harmonic, 11 into 50, 550, and high frequencies. So this is the answer for the question. Next, another question. In the single phase voltage controller circuit shown in the figure below, for what range of triggering angle alpha the output voltage is not controllable? This is very famous question. This question in fact came from previous GATE exam as well. In this particular circuit, single phase AC voltage controller, when the load is inductive, V0 is controllable. V0 is controllable if firing angle is greater than load power factor angle. What is load power factor angle here? Tan inverse XL divided by R, that is tan inverse 50 divided by 50, it will give you 45 degree. So if the firing angle is less than this 45 degree, then output voltage cannot be controlled. Okay, suppose what is the suppose if I ask the question in a reverse way, what is the range of firing angle in order to control the output voltage? In that case, you can select B, C, D options. Now, let us go to another question. In a diode, the reverse recovery time is defined as the time between the instant diode current becomes 0 and the instant reverse recovery current decays to. So this is the basic definition on diode reverse recovery time. If you draw anode current of the diode, it looks something like this. Okay, so in this case, this is a reverse recovery current, generally IRR, or but in this question it is given as IRM. Now this is the time measured from the instant where anode current is 0 to the instant where anode current becomes IRR divided by 4 or 25% of IRR. Therefore, this is TR or TRR. Reverse recovery time is defined as the time between the instant when the diode current becomes 0 and the instant reverse recovery current decays to 25% of IRM. So option C is the correct answer. Next, another question. In a single phase half bridge inverter has an input voltage of 48 volt. Inverter is feeding a resistance of 2.4 ohm what is the RMS value of the output voltage at fundamental frequency. Now just for a quick understanding, I will show you circuit diagram for single phase half bridge voltage source inverter. Okay, it looks like this. Now from this, what is the data given here? That is, total DC bus voltage is given 48 volt. So RMS value of the output voltage at fundamental frequency is equal to root 2 by pi into VDC. So this will give you root 2 by pi into 48. That option is not there. So you can also express this as root 2 by pi into 96 divided by 2, or 96 divided by root 2 into pi volt. Option B is the correct answer for the question. Now let us look into another question. Which one of the following statements express the thermal resistance between the body of power semiconductor device and the ambient? So basically this is the definition of thermal resistance. How to express that? P average is equal to Tj minus Ta divided by theta Ja, or you can also express this as theta Ja is equal to Tj minus Ta divided by P average. That means temperature difference between body and ambient, or junction and ambient, both are same, divided by average power dissipation in the device. It is exactly same as option B. Now another question. A DC to DC boost converter as shown in the figure below is used to boost 360 volt to 400 volt at a power level of 4 kilowatt. All the devices are ideal. Considering continuous inductor current, find the RMS current in the solid state switch. So what is given here? Input voltage is given, that is 360 volt. Output voltage is also given, that is 400 volt. So in boost converter, when the operation is continuous conduction, the relationship between V0 and VDC will give you V0 is equal to VDC by 1 minus D, where D is the duty cycle ratio. Therefore 1 minus D is equal to VDC, that is 360 divided by 400. So from this, after simplification, you will get duty cycle ratio is equal to 1 by 10. Next, another data point given is output power. How can you express output power? V0 multiplied with I0, that is equal to 4 kilowatt or 4000 watt. Therefore you will get I0 is equal to 4000 divided by V0, where V0 is 400. So this simplification will give you 10 ampere. Now what is average value of inductor current? Average value of inductor current, IL in boost converter, I0 divided by 1 minus D, 10 by 1 minus 0.1. This numerical value will be 11.11 ampere. Now in this question, it is not given that switching frequency, and it is mentioned that inductor current is continuous. In the case of continuous inductor current, there are two possibilities. One is with ripple, another is without ripple. In order to find out a ripple component in inductor current, we need a switching frequency. As the switching frequency is not given, you can safely assume that inductor current is ripple free. Okay, so let us write down that statement as Fs is, switching frequency is not given, we can assume that inductor current is ripple free. We can assume inductor current is a ripple free. So if inductor current is ripple free, how can you draw switch current? Switch will carry inductor current whose magnitude is 11.11 ampere. Switch will be turned on from 0 to dt, and from dt to t switch will be turned off. Now you need to find out RMS value of this switch current. Because of this rectangular pulse, how can you find RMS value? Magnitude square into function duration divided by 1 cycle, that is dt by t. So cancel this t, therefore this value will be around 11.11 into root d, where d value we calculated 0.1. Therefore it will give you that 3.51 ampere. So answer will be 3.5 ampere is the correct answer. Now let us look into another question. A MOSFET is rated for 15 ampere, carries a periodic current as shown in the figure. The on-state resistance of the MOSFET is 0.15 ohm. What is the average on-state power loss? Now in this question, generally students will do mistake like this. P average, because the question is asking that find average on-state power loss, generally students will try to write down the formula something like this. I average square multiplied with the R on. Okay. So this is not correct. Why? Because power associated with the resistance will always require RMS current. So what is the correct formula for this? P average is equal to I RMS square multiplied with R on. So you have to calculate I RMS square first. What is I RMS square? Magnitude square into function duration divided by cycle time. So this will give you 100 by 2. This is equal to 50. I RMS square is equal to 50. Therefore, what is average power loss? I RMS square 50 multiplied with R on is given 0.15. This numerical value will come around 7.5 watt. 7.5 watt. So these all the questions given from ISRO paper. So we discussed all the questions here. Alright, we discussed all the questions. So thank you for watching. I am Shankar. I am working as a faculty for Power Electronics and Control Systems at Om Institute, Hyderabad. If you are interested to looking for the services like GATE coaching or AE or AEE coaching for various PSUs like Genco, Transport Discom, different PSUs. We are offering coaching services both offline as well as online. If you are interested, you can call to this number. If you not subscribe this YouTube channel, please subscribe it so that whenever I am uploading any video, you will get a notification. If you like the content, you can spread to your friends as well. Thank you for watching.